This is going to be a video for chapter 1, section 7. So I'm going to write that up here. So chapter 1, section 7. And this is an important section because it introduces two concepts. First of all, it tells us what are equations. And this is important because you're going to be seeing a lot of equations during this year in pre-algebra, next year in algebra as well. It also introduces us the concept of solving equations. In 1.7 we're going to do this with addition and subtraction, and then we'll use other methods later on. But that's an important concept as well, solving these equations. So what are equations and how do we solve them? Well, every single equation by its nature has to have this particular sign, an equal sign. Everyone should be familiar with it. What an equal sign designates is that there is something on one side, something on the other side, and these two values are equivalent, mathematically speaking. So I can tell you that 5 equals to 5. You're probably going to think, of course, 5 equals to 5. But that's a very simple equation. Whatever is on one side is equal to the other side, mathematically, and in this case they look identical as well. But I can rewrite this as 3 plus 2 equals to 5. Now what I have on either side is not identical, but it's still 5 equals to 5. So mathematically it's equivalent. Think of the equal sign as the center of a balance scale. And whatever you put on either side of the balance scale has to equal out for the scales to be even. So this and this are mathematically equivalent, so we're still good. I can also write this down as 3 plus 2 equals to 4 plus 1. Once again, now they look nothing alike. I have addition on both sides, but mathematically they are equivalent. I can also write this down as 6 minus 1 equals to 8 minus 3. So now I have subtraction going on both sides. But once again, because this is 5 and this is 5, the end values are 5, mathematically these are all equations and they all represent essentially the same value. Now let's think of think about this and then carry this over to this example here. I'm going to go ahead and start with 5 equals 5 again. And I'm going to do this. I'm going to add 1 to the left side. Now what did I just do? Is it still equals? Is the balance maintained? No. On the left side, now I have 6. On the right side, I still have 5. So now the left side is larger. It's unbalanced. So mathematically, this is no longer an equation. Now I can fix this. The easiest way is to just get rid of this plus 1. Or, if I want to keep that plus 1 there, I can balance the scales or the equation by adding 1 to the other side. So yes, now this is technically a 6 equals to a 6, different values, but the balance is maintained. Both values on either side of the equation are now equivalent. And this is important because in the equations, the number one thing you want to maintain is balance. Now let's look at a different example. Well, let's say I have my same 5s. Let me put my black up. 5 equals to 5. And let's say I went ahead and subtracted 2 from this side. Is it balanced? No, it's no longer balanced. Now the left side is larger than the right side. The right side is technically a 3, the left side is a 5. So how can I rebalance this? Well, I can take away this minus 2, or I can apply that to the other side as well. Can't I? Now I have 3 equals to 3. Not the same values, but they are equivalent. So the balance is maintained. So what you should get out of this is that you can do whatever you want to one side of the equation as long as you do the same thing to the other side. Because your whole goal is to maintain a balance. You put something extra on one side, you have to put the exact same thing on the other side. You take something away, you you have to take that away from the other side as well. The second part of 1.7 was talking about solving equations. And to solve an equation, you have to isolate a variable if there is one present. And in most of your equations, you will have a variable present. In this case, I have a very simple equation, x plus 1 equals to 2. It's about as simple as an equation with a variable gets. Now you don't know what x is, but you know that due to this being an equation, the left and the right side are balanced. You assume that whatever equation you're given, unless told otherwise, they start out balanced. So on one side you have 2, on the other side you have an x plus 1. You can probably guess what the value for x is because there really isn't much that you can add to 1 and the result will be a 2. But we're going to solve this mathematically. So to solve an equation with a variable, you want to isolate that variable. You want to make it all alone on one side of the equation. Everything else goes on the other side. And now you look and see what is next to the variable on the same side of the equation. So this is the side of the equation we're interested in right here. And here we have the x plus 1. We have that plus 1. And I want to get rid of that plus 1. How can I get rid of the plus 1? Well, I can do the opposite. The opposites are called inverse operations. The way an inverse operation works is like this. For example, let's say I start with a 5. And then I go ahead and subtract the 2. And then I go ahead and add a 2. Where do I end up? Back at 5. In this case, the subtracting 2 and adding 2 were opposites. They were inverses of each other. Inverse operations cancel each other out. So we're going to use inverse operations to solve this particular equation. So what is the opposite of adding 1? Subtracting 1. Sure. So I'm going to subtract 1. This is going to help me get rid of this plus 1 here. Because they're opposites, plus 1, minus 1, they're going to cancel out to 0. But remember, whatever you do to one side of the equation, you have to do to the other side. Because if you don't, the equation is not balanced. So remember, in the previous examples, I had to add 1 to both sides. I had to subtract 2 from both sides. That's the wrong paper, but same examples. So in this case, I'm also going to subtract 1 from here. Now my equation is balanced because whatever I do to the left side, I also did to the right side. So let's see what we get. We get x plus 1 minus 1 is 0 equals to 2 minus 1 is 1. And 0 added to any number is that number itself. So x equals to 1. And that was technically the solution to this particular equation. Let's look at another equation. Let's say we have y minus 3 equals to 7. Just like before, to solve this particular equation with a variable, my goal is going to be to isolate this y here. And the way I want to do this, I want to get rid of everything else that's on the same side of the equation. This is the side of the equation I'm looking at. And here I have a minus 3. I'm going to use inverse operations to get rid of this minus 3. The reverse of, or the opposite of subtraction is addition, so I'm going to add 3 to both sides. And remember, I have to do it to both sides, because if I just do it to one side, it's going to unbalance this particular equation. When I do that, I end up with y plus 0 equals to 10. And once again, 0 added to any number is the number itself. So the end result is that y equals to 10. And that is my answer. That is my solution to this particular equation. As simple as that. Thank you very much for watching this. And if you have any questions, please see me at class after school or during lunch for some more help.